pattern kind of restores that almost normal escape latency time.
Okay, so you've described that generally over time they're getting faster at escaping.
Yeah.
That means they're learning to find a platform. Yep.
Would it, because would it indicate that potentially the transfer clients are finding it easier once they have the gossip data
Could do.
to escape? Maybe because either they're remembering the route that they need to escape, or because physically it's just easier for them to escape.
Those are some good hypotheses. So the gossip engine, people are saying that it's having an effect on the FAD mice, and it's helping them discover the platform easier. It's helping their learning. Do people agree with that? Yes. Why do they agree with that? Why do you agree with that? What is missing from this graph that means that I don't agree that there is a difference? There's no significant tests. So while we can say, the red line is around 40 seconds, black line is around 25, there is no significant test here which actually tells me that that difference. Sorry, have you had it?
No, it's just I want to say also that it seems like the bar are kind of overlapping.
Yes.
So maybe there's no significant.
That's a really good point as well. We'll come on to that in a second. So there's no significant test, there's no significance. They've done no statistical analysis on this to say that the FAD is worse without the drug than with the drug, or better with the drug than without it. So we can't say there was a real difference there. It's a really important scientific principle here. Unless we've done the stats, we can't say there's a difference. Doesn't matter if it looks clear as night and day, we haven't done the stats, we can't say it at a scientific level. Furthermore, just as a kind of a good ballpark when I'm looking at differences, do the error bars overlap? So generally, the error bars shouldn't overlap if there is a significant difference. That tells you that the effect size is big enough that generally it's significantly different. Not always the case. Ideally, you want to see that there is a difference. So here, you can see for this one, the error bars are there. They overlap there, so that's not a good example. But this one, for example, you can see here, the error bars don't overlap with that one. So there is it's a clear significant difference. So eyeball it. Do the error bars overlap? Could be a significant distance. However, unless you've got the stats on here, I can't say there's a difference. Alright, so there isn't a difference between any of these mice in terms of how fast they learn. Are they all able to discover the platform? Yeah? Do they all improve over time?
Yes.
Yes, maybe there's a bit of differences there. Maybe if they did more mice, have a larger effect, maybe you tease out that subtle difference. But if there is a subtle difference in learning, it's only subtle. Perhaps maybe if you looked over 10 days of training, there wouldn't be a difference. So the question is, why are they doing this? Why are they measuring these 5 days? Why bother showing this data? Yeah.
You could see if the protein is actually making the mice's memory worse or better over time. So it allows you to see what the protein is doing to the brain on a day-to-day basis.
Yeah, that's one thing. Is this actually looking at memory?
No, just the ability to escape.
Yeah, and they're getting better at escaping over time, which shows
Spatial awareness.
spatial awareness. I'd say learning would be the better way. This figure is showing that they all learn similarly. Now you don't have a mouse which is incapable of learning, and therefore we can actually then test memory. We can't test memory if someone hasn't actually learned something. And so this is a really important control graph. You see this a lot with animal experiments and most good experiments. They should always have a control figure or something in the graph which is a control, which tells the experiments are working properly. If we're going to test memory, we need to show that they've learned it first. And here over 5 days they've shown that they've all learned it. What do figures E to G tell us about the effect of gossip penton? Alright, so group at the front, do you guys want to tell me your answer quickly? What did you write down for question 2? You didn't write anything? How far did you guys get through the questions? the third question or something? Okay, that's fine. So, what does figure E tell us? Just tell me briefly, what's the y-axis telling us? That's the way we first start interpreting data. Yeah, target content occupancy. What does that measure of? Anyone help out? So what does target quadrant occupancy mean?
Start up to the quadrant with the escape.
Exactly. Think back to our. Is that working? To this bit, we've got our quadrants. We've been training the mice up for the last 5 days to find this platform. On the 6th day, measuring memory 24 hours afterwards, we're taking that platform out, and then we're spending how much time do we spend in the quadrant where I think it should be versus all the others. And the assumption is we're spending more time here than the other ones, and we're assuming that they've remembered where the quadrant is. So, wild type versus Alzheimer's disease mouse. Does the Alzheimer's disease mouse have more memory? What makes you say that? Shows a significant difference. Those asterisks, all important. Does it matter whether there's two?
It shows the level of significance.
Yep. Level of significance. So you've got 0.05, 0.01, 0.05, 0.04. The more asterisks, the more significant, but that doesn't really make a difference at a scientific level. If it's significant, we're saying it's a real effect. You could say highly significant, but that will just say another point. Does gabapentin improve memory? Seems to. What are you basing that on? Perhaps a group at the top. Does gabapentin improve memory? Is that a yes or?
Yes.
Yes? Why do you think that is, Mel?
They spend a longer amount of time in the target quadrant.
Yep. And that's a significant difference. So it significantly improved the amount of time in the target quadrant. So that mouse, once it's been given gabapentin or that cohort of mice, you can remember. Is it different from wild type? How much does it improve memory? Doesn't say it. They haven't actually done that. But well, you could say that, oh, maybe it's restored it to normal levels. So actually, because that's always the difference when we're looking at drugs. Does it restore it to normal, or is it only a partial rescue? So F and G, these are both control graphs. Again, like this one, they show no significant difference. Why do we think that's important? So again, we're checking memory here. We want to check memory, not learning, not anything else. How do we ensure that the mouse, because the assumption here is that the mouse is spending more time in the quadrant because they've remembered where it is. What other factors could lead a mouse to stay in one quadrant over another?
It's happy and understands that learning.
Yeah, but that's the hope. Maybe they're just going high off it. Yeah.
I remember from a previous experiment, like they did with like experimented with processed food, and mice was completely black and going like
Yeah.
yeah.
So maybe it could be going round and round in circles. Could be yeah, the diet could be a factor behind that. You were saying something?
Well, they are pretty much all over the same distance.
Yeah.
But it shows you even how long they were in the quadrant that you want to be in.
So they've all got the same swimming capacity, would you say? Is that important? Yeah.
Yeah, that means they're not physically impaired, just asking why they didn't go to the same.
Yeah, exactly. They're not physically impaired. It's not that a mouse has got really tired and just given up and started floating there. Because mice float. I mean, that's why this is a safe test. They like swimming around, but they're just going to stop swimming. And if they just stop swimming, they're going to get really high quadrant scores. And that's just an important thing to rule out. We're trying to test memory, and they haven't just. The reason why they might be more in the target quadrant isn't because they can't swim and they've given up now. It's because they remember that. We can't get into the mind of a mouse, so we're trying to get into the mind of a mouse, so we need to rule out other things. Okay, so So here you get onto gasopentin now. Why is this important? Building on our lecture, does anyone know what donepezil does? Yep.
It's acetyl
Yep.
cholinesterase
It's a bit of a mouthful. Yeah, acetylcholinesterase inhibitor. Yes. Why is that important in Alzheimer's disease?
It's the drug that is given to dementia patients in diagnosis to kind of reduce the amount of acetylcholinesterase that is present and what's the correct term?
So they've reduced the amount of acetylcholinesterase, so they're reducing the degradation,
Yeah.
increasing the amount of acetylcholine. Acetylcholine is important in memory, and we know that improves memory generally. So why have they tested it here? Does gasopentin inhibit acetylcholinesterases? Not really. But does it improve memory? How is it working? That's kind of what they're teasing with this figure, is what is the mechanism? We found a drug that maybe works through a different mechanism than anything else. And therefore, if it's a different mechanism, we could then add it with donepezil to hopefully improve memory more. Or when donepezil stops working, because there are no acetylcholinesterase neurons, we can give this one instead. Okay then, figure 2. So here we've got 2 different techniques, immunohistochemistry or Western blotting. Can anyone tell me what immunohistochemistry is? Yep.
Using the antibodies to stain tissue,
Mhm.
look at certain structures within like the brain and the body.
Exactly right, yeah. So we use antibodies here to visualize things. And they've used antibodies in this book, but they've used it to visualize amyloid plaques. And that allows us to see how many amyloid plaques or where the amyloid plaques are in the brain. It gives us spatial data and structural data. What's Western blotting then? Someone else? Yeah.
Analyzing the protein amounts in a certain part of the body.
Yep.
For instance.
Exactly. So basically taking the hippocampus here. Why have they taken the hippocampus? This is modern memory. That's important in Alzheimer's disease. And then they've looked at it for different proteins to see if there's a difference in the level of protein. Okay, so let's interpret this then. I'll give you guys again 15 minutes.